In the name of Allah, the Beneficent, the Merciful. Welcome to the world of physics. Due to coronavirus, we have to continue our online class. At first, I'd like to suggest you stay home, stay safe. Let me introduce. I am Muhammad Muktadir Hosen, lecturer, Department of Physics. And at first, observe this diagram. Here, the name of the diagram is shown here. That is Diode. This is a symbol of Diode. And observe this diagram. Actually, all of you already introduced with this diagram. This is the diagram for a transistor, and it has three sides, that is emitter, base, and collector. And there's a block diagram for transistor. First one is NPN transistor, and second one is PNP transistor. And we all know that transistor have three sides, that is emitter, base, and collector. And in this diagram, the direction of current also shown for PNP and NPN transistor. In left side, we have a NPN transistor. First one is block diagram, and second one is and in below in left side, that is the circular diagram for NPN transistor, and the direction of current, that is IE, is in outer direction, and the direction of current, that is here, the direction of current is IE. Here the direction of current, that is IE, it is comprised with IB and IC, and we can say that IE is the combination of IB plus IC. Here IC is the collector current, IB is the base current, and IE is the emitter current. And in the same way, we can explain also PNP transistor. That is here the current of IE is divided between IB and IC, and we can say that IE is equal to IB plus IC, and the direction of current for IE is inside this direction. And here the difference between PNP and NPN is based on the direction of current. Here all of you know the name of the chapter, that is Modern Physics and Electronics, and this is our second lecture. And here the learning outcome for you. After this lesson, all of you will be able to explain the Diode and IB characteristics of diode, and you can write the necessary equation for this chapter, and we can draw the diagram of collector base transistor. And here the first question is, what is diode? Diodes are a special kind of diode which permits current to flow in the forward direction. What makes them different from the other diode is that generators will also allow current to flow in the reverse direction when the voltage is above a certain value. Here the block diagram of a generator is shown, and in a generator there is allow current to flow from its anode to its cathode like a normal semiconductor diode, but it also permits current to flow the reverse direction when its general voltage is reached. And here generator can be used as a voltage regulator. The term regulator means which regulates or control. That is, a generator can work as a voltage regulator if it is introduced in circuit. The output across the diode will be constant. It is driven by a current source. As we know, if the voltage across the diode exceeds a certain value, it would draw excessive current from the supply. The basic diagram of the generated as voltage regulator is given in picture. Observe this picture, and it's the a basic diagram of generator as voltage regulator. Here our input voltage is V1 and our output voltage is V2, and here the generator that is used as a voltage regulator. And uh, with the help of these uh, help of these graph, we can show that the voltage that is proportional to current, and if the voltage is decreased, and then the current will be decreased. And in the normal diode, that can be used as a regulator. Here, if the line is dotted, then we can say that it is unregulated voltage. And here the generator can be used as a voltage regulator. That's why it follows the curve that is shown in yellow color. Here, uh, or related to a topic that is Zener breakdown. It's a phenomena of a Zener breakdown that is related to the concept of avalanche breakdown. That is, a Zener breakdown is achieved by heavily doped region in the neighborhood of ohmic contact. It is the second method of disturbing the covalent bond of the crystal atom and increasing the reverse bias generator current to be sustained at a much lower specific voltage than normal diode. And here, the reverse bias voltage known as Zener voltage, where this mechanism occurs as determined by the diode doping concentration, and it occurs when the depletion layer filled width is sufficiently enough to disrupting the covalent bond and cause number of free charges carries due to the electric field generation to swell. And here is the curve for IB characteristics. And here in forward direction, with the increase of voltage, the current will be increased. There is and forward voltage and forward current is shown here. Uh, with the help of this curve, forward voltage and forward current is shown. And here in reverse direction, we increase the voltage, but the current is not increased as much. And here after any voltage, after a region, with the increase of uh, voltage, the current increases so rapidly, and this region is known as a knee region. This region is known as a knee region, and here in below knee region or below knee voltage, the all the current that we observe for voltage, that is leakage current. Here, the definition of leakage current is important. In reverse direction, we have this reverse current, and with the increase of voltage, we have rapid current. And after this knee region, we have much current, that is and this voltage is known as a breakdown voltage for in diode. And here, uh, just think about it. And this this voltage is breakdown voltage for any other diode, but in generator, uh, generator can pass electricity or current that is in reverse direction. And for forward bias, with the increase of voltage, we have current. Uh, and if the voltage is 0.07 volt, then um, we have saturation of current. And makes and for forward bias, we have current uh, very easily. But in reverse direction, we increase the voltage, but we didn't get any certain amount of current, and the current is so low, that is 5 milliampere, and this current is known as uh, uh, known as leakage current. And after certain amount of voltage, with the increase of voltage, the current increases so rapidly, and this voltage is known as Zener voltage, and this point is known as a knee point, or and this region is known as knee region. And knee region and knee voltage and leakage current, all these happen in reverse bias. And in forward bias, we only have saturation current. And here the difference between forward and reverse bias, that is, in forward bias we have a large amount of current with the increase with the small mm, with the increase of with the short increase of voltage. But in reverse direction, we increase voltage so much, but uh, the current is uh, n- not not enough to uh, not enough, but here the current is very low, that is in milliampere, 5 milliampere region. Here, generator IV characteristics. Generator is used in the reverse bias mode. That is, and connect to the negative supply from its IV characteristics are above. Here, we can say that the generator has a region in its reverse bias characteristics of almost a constant voltage regardless of the current flowing through the diode. This voltage across the diode is a general voltage, and it remains nearly constant even with large change in current through the diode caused by variation in the supply voltage or load. Uh, the ability to control itself can be used to great effect to the regulate or stabilize the voltage source against supply or load variation. The diode will continue to regulate until the diode current falls below the minimum IZ value, and that is in reverse breakdown region. And this is the IV characteristics curve for any diode. We have forward bias region, and we have uh, reverse bias region, that is a Zener breakdown region. And in uh, certain area, we have minimum of I minimum, um, uh, and with the increase of voltage, we have uh, maximum amount of current, that is constant Zener voltage, and this voltage is constant Zener voltage. And uh, here the anode and cathode, and for uh, the symbol of normal diode and Zener diode is shown. And these are the IV characteristics. And we have uh, two bipolar junction transistor, that is PNP and NPN transistor. And this is the block diagram for two PNP and NPN transistor, and it have three terminal that are known as emitter, base, and collector. And there are two junctions, so transistor can be considered at two diode contact back to back. And naming of transistor terminal, there is three section dope semiconductor. And the one side direct is known as emitter, and the opposite side known as called as collector, and the middle section is called base. And first one, that is emitter, the section of one side that supplies current is called emitter. Emitter is always forward bias with respect to the base, to its current supply carrier. And NPN transistor emitter supply holes. Here in NPN transistor, emitter supply holes to its junction. And PNP transistor, PNP transistor, uh, mm, that emitter supply electron to its junction, and other side is known as a collector, and the section of the other side collector that collects carrier is called collector. The collector is always reverse bias with respect to base. For NPN transistor, collector receives hole from it to its junction, and for PNP transistor, collector receives electron to its junction. And the middle part is called base. And important factor to be remembered, that is the transistor has three regions named emitter, base, and collector. The base is much thinner than other region. Emitter is heavily doped, so it can be inject large amount of carrier into the base. Base is lightly doped, so it can pass most of the carrier to the collector, and collector is moderately doped. And the junction that is between emitter and base is called emitter base junction, and junction between base and collector is called base collector base junction. The emitter diode is always forward bias, and collector diode is always reverse bias. The resistance of emitter diode is very small. There is in forward direction, and resistance of collector diode is very high. That is in reverse direction. And the operation of NPN transistor is shown here in forward bias, emitter base junction, and reverse bias there is collector base junction, and forward bias collects electron to move towards the base that constitute the amount of current, that is IE. And uh, uh, as this electron flow toward p-type base, uh, they try to recombine with holes. As base is highly doped, only few electrons recombine with hole within the base. These recombined electron constitute small base current, and we can write the equation, that is IE is equal to IB plus IC. And that is very important for us to calculate emitter current, base current, and collector current. If you know the base and collector current, then we can calculate with the help of this equation, that is I is equal to IB plus IC. And operation of PNP here, the forward bias is applied to emitter base junction, and reverse bias is applied to collector base junction. And the forward bias is emitter base junction causes hole to move towards base, and this constitute emitter current. And here the holes flow towards the n-type, and they recombine with electron. As base is highly doped, only few hole recombine with electron within the base. Here the recombined holes constitute small base current, um, uh, uh, and the remainder hole cross base and constitute collector current. And the symbol, transistor symbol, is shown here. That is the direction is shown with the help of these PNP and NPN transistor diagram. And here the common thing is that emitter base junction is forward bias, and collector base junction is in reverse bias. That is here n-type is connected to its negative terminal, and p-type is connected with positive terminal. That's why this junction is forward bias, and here the p-type is connected with negative, and n-type is connected with positive. That's why the second junction, that is base collector junction, that is always in reverse direction. That also applicable for PNP transistor also. And here this voltage is forward voltage or forward bias, and this is in a reverse bias direction. And that's why we can get the current, that is I is equal to IB plus IC. And uh, and we have three modes for transistor operating mode, that is active mode. And base emitter junction is forward, and base collector junction is reverse direction. And saturation mode, that is base emitter junction is forward, and base collector junction is forward direct and forward bias. and cutoff mode, that is both junction are in reverse bias. I think it's we always use the active mode for transistor. Saturation mode and cutoff mode, these two modes is not uh, severely used in daily life, but we always use active mode of transistor, and we have three common connection for transistor, that is common base, common emitter, and common collector. And for common base collection, look in the figure that there is base is connected with emitter, and this base is also connected with collector. That's why this connection is called common base connection. And here, whatever it is, PNP or NPN transistor, if the base is connected with both emitter and collector, and this connection is called common base connection, and the figure is shown here. And for common base collector connection, we have current amplification factor that is denoted by alpha, and we can write the ratio of the change of the collector current to the ratio of the uh, to the change of the emitter current. That is at constant collector base common base connection is known as amplification factor, and the value of the alpha is less than unity, but the range is 0.9 to 0.99. And expression for the collector current, that is IC, and we can write the equation, that is I is equal to IB plus IC, and we can write the equation. So if the collector current constitute portion of emitter current, that is alpha E, and ICVO, that is leakage current, then the collector current is also written as the equation alpha E plus ICVO. Here ICVO is leakage current, and the emitter current portion of emitter current is alpha I. Expression for collector current is shown here, and we put the value of IE, that is IC plus IB. By putting this value and after calculating, we can write the equation for collector current, that is alpha by 1 minus alpha into IB plus ICVO divided by 1 minus alpha. There is the equation for collector current, and the relation between alpha and beta. Here the beta is current gain, that is beta is equal to IC divided by IB, and we know the alpha is IC by IE, and we know the equation for equation that is IE is equal to IB plus IC, that is for DC current. And for AC current, we have the equation, that is delta IE, that is change. We have to calculate the change, and by putting this value of IB in first equation, that is the for equation beta, and after that by dividing this all this term with alpha delta IE, delta IE, then we can write the uh, write this line, that is IC by IE is equal to alpha, and IC by IE that is alpha, and we have final equation, that is beta is equal to alpha by 1 minus alpha. This is the uh, relation between alpha and beta. Actually, this is the equation. This is the relation between alpha and beta. And expression for collector current, that is that we discussed earlier, that is alpha. IC is equal alpha I plus ICVO. Here ICVO, that is in common base operation, that is leakage current, and alpha is a portion of emitter current, and IC is collector current. And by putting the uh, value of IB plus I is equal to IB plus IC, we put the value of IC in the second equation, and after calculating, we have the equation for IE. I think you should write this equation uh, to solve mathematical problem. And here the relation of alpha and beta is also shown. And uh, the equation for I equation for emitter current, that is I is equal to 1 beta plus 1 into IB plus beta plus 1 into ICVO. And we have finally we have a equation that is beta is equal to alpha by 1 minus alpha. I think you may have some question that is related to our topic, and you can ask me in our regular class time. And there is a home task for you. Explain the concept forward and reverse bias, explain IV characteristics of Zener diode, and write necessary equation that we have discussed in previous 2 or 3 slides, and draw the diagram of common base transistor. That's the all the home task for you. And I'd like to suggest you stay home, stay safe, and thank you for uh, joining with us. Allah Hafiz.